Hi, everybody. Miss Heather here with some help and support on how to do the assignment for model number 2. So what I'm going to go through are 3 examples of your classmates' models that have really wonderful features in terms of explaining cars and combustion chemistry. And I'm going to go through how you can use the rubric as a tool to check to see if you've got all the components that we've learned, and also some support on the reflection questions. And so I hope that this is helpful for everybody. So let's start by looking at this example of one of your classmates' models. And so the first thing that I notice here that's really helpful is that the different steps are numbered. You see 1, 2, there's 3 over here, and then 4. And so I know the order in which fuel moves through the car. What else is really important? So this student here says that gasoline is made up of CHN. And so what this is describing, I'm going to try to draw here. Let's see if I can scribble. Right there, CHN. So this student is using her or his knowledge of chemistry and elements and atoms to describe that the fuel, gasoline, is made up of these 3 elements: carbon, hydrogen, and nitrogen. And that is a really great way to use our chemistry knowledge from the periodic table to explain fuels. The next thing that's really wonderful that this person has here is that she is talking about energy, right? So we see right here in step number 2, the gasoline makes an explosion. And so I learned that combustion is an explosion and that energy is part of this process and is in fact what makes the car move. So that's step 2. Step 3 over here has another really important part of the chemistry and one of our vocab terms from class, which is the conservation of energy. The energy is conserved in the engine. And so that means that it's not created or destroyed, but there's a transformation that's happening. And that energy is what helps power the car. And that's the motion of the car. And then, and then the last thing that I want to point out here is the discussion of exhaust, and also a discussion that this person says the gasoline combine, and even though it doesn't look like it, the gasoline still has carbon, hydrogen, and nitrogen. So she's talking about conservation of matter in that the same atoms that went into the fuel are still there in the exhaust. So there's some really wonderful components of the chemistry that we've learned here. So now let's see how we can use the rubric to go back and check if this person could add anything to her model, right? So does the model have titles, labels, and descriptions? Yeah, absolutely do, with arrows that represent chemical reaction changing the fuel. So we definitely have that in the order of the numbers. That shows the flow from 1 to 3. So that's great. Description of labels including products and reactants. So let's go back and check. So she has CHN as the fuel that goes into the fuel tank. That's the reactant, but actually she's missing the name of the product. And so we know that the products of combustion reactions are carbon dioxide and water. So something that this person could go back and do is add that CO2 and water come out of the exhaust pipe, and then she'll have all of the reactants of the reaction. So we're not going to give her a check mark there for that one. But let's move on to the next one. Explain how fuel changes through combustion. So yeah, so that's the explanation that there is a transformation of the fuel, but that it's conserved, which is this last one down here. She discusses both matter and energy can be conserved, and she did explain how the energy is what moves the car forward. So there's just this one missing, so that's going to be a 4 out of 5. And so identifying that this was missing would allow you to go back and make a revision before you hand it in. So I hope that's helpful. We're just really quickly going to look at 2 more examples from your classmates to highlight some different styles. So here on this one, the first thing that I notice is here at the bottom, the chemical reaction, which you can get right out of your notebooks, is described here. The spark, which is the fire, the air and the gasoline all combine, those are the reactants, to make the products of smoke or exhaust, and the explosion, the energy, right? So that's great to include. And then what we see as we move through the flow of the car across the arrows is that this concept is incorporated, right? So right here, we get a description that the gasoline and the air are going to mix, which is what happens on this side of the equation right here. And then this student goes into a little more detail than the last one about how the car moves forward, specifically describing the energy of the combustion reaction moving a piston downward. So that really, really gets into the physics, and this is super detailed from the video. Both this student and the last student did a totally wonderful job of explaining the motion part. So I just wanted to highlight that one. And then over here again, when we're talking about the exhaust, there is a discussion of matter being conserved, but just changed. And this student, just like the last one, could benefit from including that exhaust is made up of carbon dioxide, CO2, and water vapor. So using the rubric would help them go back and identify that. And then one last model to look at, what I noticed right away is, again, numbers that show me the flow, and the arrows also show me the direction of the flow. And these little stars, I think, are meant to represent the explosion, which is really cool to include. The other thing that I just wanted to point out from this one is, again, here we have a description of the atoms that are involved in fuel: hydrogen, carbon, and oxygen, right? And that's why our fuels are called hydrocarbons, because they have hydrogen and carbon. So that's really important. And then something unique that this student did that I find helpful is that they included a comparison here between firing a gun and the energy that pushes a bullet forward and the explosion that happens in an engine to move the wheels forward. So any little things like that that help you make sense of combustion, you can include that there. And then again, this student included the reaction down here. And so we've got exhaust and we've got CO2 as the product. So that's a great way to use the chemical name. So the last thing I want to include is these reflections and what you can think about writing here. So the first question on the reflection was asking, what does your model help you explain about combustion? And when I look at these three models, I learned a couple of important things. The first thing that I learned is that in a combustion reaction, they're always the same reactants. And I'm just going to type here. Reactants are hydrocarbons, and I know the exhaust is the product. And after some revision, I would know that the exhaust includes CO2 and water. So that's something really important that I learned. Geez, sorry. H2O, sorry. That's something really important that I learned about combustion. What else did I learn? I learned that there is an explosion, right, that releases heat and releases energy and heat, and that is what moves the car forward. And so that explosion is what happens in a combustion reaction. Sometimes it's a fire, like when you have a campfire or a match and a birthday candle. It's a little tiny explosion, and it's contained in just that little flame. And then in a car, it's a much bigger one that moves the pistons forward. And then something else I learned is that the fuel is not destroyed, but it's transformed. So from these models, I learned about the law of conservation of matter and energy. So that's something really unique that I learned about combustion from these models. For the second question here, what does your model help you explain about cars and fuel? There's a couple of things I learned. First, I learned that the order of where the fuel moves is really important, right? I can't start out in the exhaust pipe and then send my gasoline up from the back. That's not going to work, right? The order of matters in this combustion reaction, right? I also know that a car won't run without fuel, right? But I'm left wondering, does the fuel type matter? And we know from our other investigations that vegetable oil can work. There's a couple of things that I didn't learn from this model, and that's okay because it wasn't part of the assignment. You can probably hear my baby crying, so I'm going to wrap this up. But I did not learn from this model about the economics of gasoline or vegetable. I didn't learn how much it costs. I didn't learn where the oil and the gas come from. I didn't learn about the air pollution that's caused in neighborhoods like Wilmington. So this model did not help me learn everything, but it did help me learn a lot of things, which is wonderful. And so future models maybe will tackle some of those issues of justice and place and community, but that wasn't the job of this specific model. So that's not something I would write about here, but maybe in a future model. Okay, that's it. I hope that was helpful, and let me or Ms. TIEU know if you have any questions, and thank you so much.